All right, so for this section, what we're going to do is look at just sort of a quick method to graph some of these transformations on exponential functions. Yeah, we want to avoid using that transformation method, which requires us to graph like 4 or 5 pictures on the same axis. So instead, what we're going to do is use some of the details that we found while drawing other exponential graphs in the other video, and use those to come up with actually a pretty quick sketch of these curves. We know that they're really simple curves. They're not straight, but they are curved. We know that one side uses a horizontal asymptote, and we know that the other side is sort of infinite behavior. So all we actually really need to figure that out, instead of doing a bunch of shifts and stretches and things like that, all we really need to find is the horizontal asymptote and a few points. I'll always just probably find 2 points. So let's find a horizontal asymptote and let's say 2 points. So the horizontal asymptote, any standard graph of the form y equals a to the x is going to have a horizontal asymptote of y equals 0. So if we look at this graph on the left here, the number a, letter a, f of x equals -2 to the x plus 3. This part here is our base graph of this a to the x, where a is 2. And we have a plus 3 on the outside. So I actually don't care so much about that -2 to the x, because this part is going to be flat to near 0. The horizontal asymptote is actually just the shift, right? So if I take that a to the x and I take the horizontal line that goes with it, if I shift this up or down, it's going to move the horizontal asymptote with it. So the horizontal asymptote always comes from the vertical shift. So that's going to be a horizontal asymptote, not 0 at 3, because it's that shift up by 3. Standard 0, that plus 3 on the outside of the exponential part of the function pushes it up by 3. Next, what I'm going to do is just find 2 points. I'm going to plug in 2 numbers. So I'm going to plug in 2 easy numbers. So let's say x equals 0. F of 0 is -2 to the 0 plus 3. Just be careful with your algebra, but that should be 2 to the 0 is 1. And so it's -1 plus 3 is 2. So I've got a point at 0 and 2. And I'm just going to plug in 1. So f of 1 is -2 to the 1 plus 3, which is -2 plus 3, which is 1. So I've also got a point at 1 and 1. And what I'm telling you is that that's going to be enough to basically draw my graph. So I'll get my axis done. All right, I've got my XY axis. So what I'm going to do first is draw out that horizontal asymptote at y equals 3. So that should come in right about there. And I'm just going to make that dotted so that we know it's not really part of the graph. So I'll just kind of erase little sections of it. This. Doesn't give me a make dotted line function in this whiteboard. So we've got our y equals 3. All right, so the next thing I'm going to do is plot those 2 points, my green points, so my point at 0 and 2, and at 1 and 1. So this is enough to tell me a lot about this graph. So if I'm going to connect all the dots now, I know I have to use the horizontal asymptote on either left-hand side or the right-hand side. So if I wanted to use it on the right-hand side like this, well, to connect the dots, I'd have to then go down to the green dot and then back up to the right to get to that horizontal asymptote. And that doesn't happen in an exponential function. Remember that all these functions just kind of look like this when I graph them. That's got too many bumps in it. So that is not what's going to happen. And what that tells me then is that it must use actually the left-hand side for the horizontal asymptote. So I'm going to get rid of that. And so if I use the left side, I'll just get this nice little swoop. You should be able to see, yeah, it goes strictly down, right? Or is that one I drew before, it went down and then up, which we shouldn't have. So this would be a pretty good sketch of what this graph is going to look like. It's got all the information that I would want. So this will be it. Yeah, so we'll just do exact same thing for the second one. We're going to find the horizontal asymptote. Again, it's just going to be that shift there. And that'll be down by 4, so it'll be at y equals -4. I'm going to get 2 points. 0 is usually a pretty good one to plug in. If we try 0 right now, what's going to happen? I'm going to actually get 1/5 of to the -3 minus 4. That's 125 minus 4 is too big. So that might not be the one that I want. What I'm going to do is actually plug in 3, mostly because if I plug in 3, I'm going to get a 0 up there, and exponents of 0 are nice. So g of 3 is 1/5 to the 0 minus 4, which is 1 minus 4, which will be -3. So that will give me my point at 3 and -3. It just be mindful of like avoiding fractions. If I want this to turn into an integer, I want the exponent to be negative. So if I try 4, then my power is going to be 1, and then I keep that fraction. So I don't want that. I'm going to actually do 2, because that's going to give me 1/5 to the -1, which is going to flip it and turn it into 5. And that way I get a nice integer. It's not the end of the world if you don't get nice numbers. It's just going to be easier to graph. So I'll have a point at 2 and 1. And yeah, that should be enough for me to come up with a pretty good graph. All right, so I've got my axes. I will start by drawing that asymptote at -4. So it'll look like that. And as always, let's get rid of, turn into a dotted line. Sure, there's a better way to do this. I'm not a boomer, but I'm almost there. Plot my 2 points. 3 and -3, 2 and 1. And so, yeah, again, it's just going to be a matter of what side of that horizontal asymptote are we going to use. So if we do connect the dots, remember I said it shouldn't always go up or always go down. So if I'm going down from the first point to the second, I have to keep going down. And then with these graphs, it shouldn't ever cross that horizontal asymptote for these exponentials. So that does tell me that it's going to go down, and instead of plowing right through the horizontal asymptote, it's got to sort of level out there instead. I would like that to look a little bit more curved, but it should kind of eventually start looking pretty much straight up. My graph's not great. Hopefully you get the idea there. It looks like it's leveling out to a flat line. I wish it didn't, but that is just me not drawing very well. Try and shave it to look better. Yeah, so something like that. You'll notice this one with that small inside, that small base of 1/5, it's less than 1. That's causing the horizontal asymptote to be on the right-hand side, basically, because every time you add something to x, it means, or you add 1 to x, it means multiply by 1/5 again, which means make it a lot smaller. And so that's why it levels out on the right side, whereas on the left side, moving left by 1 actually means dividing by 2. So that's where the leveling out occurs. So you could remember all those little fine points for drawing these graphs, but I like this method of just like asymptote, 2 points, connect the dots. It's pretty hands-on, and so it works for me.